Hi students, welcome back to chemistry classes. We were studying about the chapter surface chemistry and today we will discuss about colloids. What are colloids? This is an important thing. Colloids are what? Heterogeneous substances. It is a heterogeneous system. Colloids is a heterogeneous system in which the particles, one substance is dispersed as very fine particles in another substance. One substance, that is the dispersed phase. It is called as dispersed phase. One substance called the dispersed phase is dispersed as very fine particles in another system. That is called dispersion medium. Dispersion medium. A colloid is a heterogeneous system in which one substance is dispersed as very fine particles in another medium. That is called the dispersion medium. Okay, and the fine particles are called as dispersed phase. Students, we have already studied in our 9th class about mixtures. Mixtures are of two types mainly, that is homogeneous and heterogeneous mixtures. That we already know. Homogeneous means only one type of molecule or particles, and heterogeneous means more than one type of particles. Homogeneous particles are also classified as what? True solutions. This may be a new term. They are true solutions because they vary in their particle size. That is, the size is less than 1 nanometer. Where the heterogeneous substances are classified as two types, they are colloids and suspension. About colloids we are going to study today. Colloids particle size is 1 to 1000 nanometer, and for suspensions the particle size is what? Greater than 1000 nanometer. Remember the particle size. For colloids it is 1 to 1000 nanometer, and the suspension, the particle size will be what? Greater than 1000 nanometer. So we can define a true solution as what? It's a homogeneous mixture in which small particles are dispersed throughout the solvent and the particle size is less than 1 nanometer. A colloidal solution can be defined as a heterogeneous solution. It's a heterogeneous solution in which the particles are of what? Intermediate size, that is from 1 to 1000 nanometer. In this way we can define a colloidal solution. The next is suspension. Suspension is what? It's a heterogeneous mixture where the small particles, it has small particles but they are insoluble particles. It's a heterogeneous mixture which contains small insoluble particles and the particle size is what? Greater than 1000 nanometer. So we understood that the true solution and the suspension and colloids, they differ by their particle size. Remember, the particle size is important. We can take a glass of water as an example of true solution, milk as an example of what? Colloid, and also sand in water as an example of suspension. Sand in water means we can see the sand particles. That means the size is greater than what? 1000 nanometer. Bigger size particles will be there in suspension. Let's discuss about the different phases in a colloidal system. What are the different phases? The first phase is what? Dispersed phase. Dispersed phase means the particles that are dispersed. It is the component that is present in small proportion. The component that is present in small proportion is called what? The dispersed phase. And the dispersion medium is the medium in which the colloidal particles are dispersed. The medium in which the colloidal particles are dispersed is called dispersion medium, and the what? Medium where so the particles where small particles that are going to be dispersed are called as what? Dispersed phase. They are present in small proportion.
Depending upon whether the dispersed phase and the dispersion medium are solids, liquids or gases, there are 8 types of colloidal systems. A gas mixed with another gas is not here. You can look at gas with gas is not there. Why? Because they are miscible and there is no such colloidal system, gas in gas. Okay, let us look in detail. Solid, when the dispersed phase is solid and the dispersion, the medium is also a solid, then we call it what? Solid salt. Some of the examples are colored glasses, some of the colored glasses and the gemstones are examples. When a solid is in what? Liquid medium. Dispersion phase is a liquid. Solid in liquid is called sol. Solid in liquid is called what? Sol. Paints, cell fluids are the examples. Paints and cell fluids are the examples of sol. The third category when the dispersed phase is solid in gas. That is aerosol. Solid in gas is called aerosol, and the examples are what? Smoke and dust. Smoke and dust, they are aerosols, solid in gas. These are the three classifications with solid as the dispersed phase. The next classification is what? Liquid as the dispersed phase. Liquid in solid is called gel. Cheese, butter, jellies will be the examples. Liquid in liquid is called emulsion. Liquid in liquid is called emulsion, and milk and hair creams are examples. Liquid in gas is called aerosol. There are two aerosols. Solid in gas. Solid in gas is called aerosol, and also liquid in gas is also called as aerosol. Examples are fog, mist, cloud, insecticide sprays, etc. These are the three classifications of liquid: gel, emulsion and aerosols. The last two is gas in solid and gas in liquid. Gas in solid is called solid sol. Pumic stone, foam, rubber are examples. And gas in liquid is called as foam. Gas in liquid is what? Foam. Froth, whipped cream, and soap lathers are examples. Among this, the most common are what? Salts. Salts are common, gels are common, and also emulsions. What is a salt? That is salt in liquid. Salt, then liquid in salt is gel, and liquid in liquid is emulsion. This chapter mainly deals with salts and also what? Emulsions.
Now we can study what is the classification of colloids based on the what nature of the interaction between the dispersed phase and the dispersion medium. Based on their interaction, how dispersed phase and dispersion medium interacts, we can classify colloids as lyophilic and lyophobic. Lyophilic and lyophobic, solvent loving and solvent hating. Let us look into the characteristics of lyophilic colloids first. Lyophilic salts we can see. What is first about their preparation? They can be prepared by direct mixing with the dispersion medium. When the dispersed phase can be directly mixed with the dispersion medium to prepare. Next is the particles will not have charge. That is no charge on the particles present. And they are reversible. Means after the colloid is formed, they can be what? Reversed into dispersed phase and dispersion medium. They are reversible. The particles are generally solvated. The particles will be usually solvated in nature, and the viscosity of the dispersed phase will be higher than that of the dispersion medium. Viscosity. Next property is what? They can be precipitated by electrolytes. When we add electrolytes, the particles in the colloidal solution can be precipitated. The colloidal solution, when we add some of the electrolytes, they can be precipitated. The particles will precipitate to the downside. And the next property is they will not show Tyndall effect. These are some of the properties of lyophilic salts or lyophilic colloids. What is the first property? They can be prepared directly by mixing with the dispersion medium. They are reversible. That means we can reverse them into dispersed phase and dispersion medium. They will not show Tyndall effect. And the next point is what? The particles are generally solvated. There is no charge for the particles. Okay, this I wrote. These are some of the properties of colloids. What colloid? Lyophilic colloids. Lyophobic colloids. The characteristics will be what? Opposite to that of lyophilic. Lyophobic will be opposite in character. Let's look. The lyophobic colloids are not prepared by direct mixing. That means we cannot prepare this colloid by direct mixing the dispersed phase and the dispersion medium. And the next characteristics is they are irreversible. We cannot, after the preparation of the colloid, lyophobic colloids, we cannot separate them into dispersed phase and dispersion medium. That is, they are irreversible. The particles will carry a charge. They will have either a positive charge or a negative charge. So what happens? They will either move to cathode or anode as they are charged particles. Next point is the particles will not undergo what solvation. I told in lyophilic colloids that the particles are solvated, but here there is no solvation. And also the viscosity of the colloid will be same as that of the dispersion medium. Viscosity will be almost same as that of the dispersion medium, and the colloids can be precipitated by low concentration of what? Electrolytes. The last lyophilic colloids, what I told, they can be what? Precipitated by high concentration of the electrolyte addition. Here we can precipitate it by low concentration of electrolyte addition. They will precipitate if low concentration of electrolyte added itself. The high concentration is not needed. The next point is what? They exhibit Tyndall effect. These are the important points of lyophobic colloids. There is a chance to ask the difference between lyophilic and lyophobic colloids. It is easy to score marks. This type of classification is based on the particles of the dispersed phase. Types of particles on the dispersed phase. Based on that, we can classify colloids as multimolecular colloids, macromolecular colloids, and also what? Associated colloids. These are the three classifications based on the types of particles of the dispersed phase.
First, let us look at the difference between multimolecular and macromolecular colloids, and then let us discuss what? Associated colloids. Multimolecular colloids are formed by the aggregation of large number of atoms or molecules with diameters less than 1 nanometer. They are formed by the aggregation of large number of atoms or molecules. While the macromolecular colloids are formed by large size molecules. Molecular mass of the multimolecular colloids are intermediate and that of macromolecular are high molecular mass. The particles or the molecular mass of the particles are intermediate while the molecular mass of the macromolecular colloids are high. The particles are held by weak van der Waals forces. Weak forces are called as van der Waals forces. These are the force of attraction that helps the particles of multimolecular colloids, and in a macromolecular colloid, the particles are held by stronger van der Waals forces due to the presence of long chains. Multimolecular colloids are lyophilic, solvent loving, while macromolecular colloids are lyophobic in nature. Examples of multimolecular colloids are salts of gold and sulfur, and also polymers like rubber, nylon and starch are examples of macromolecular colloids. These are the main differences between a multimolecular colloid and macromolecular colloid. The third classification is the associated colloids or micelles. The term micelles. Some of the substances, they behave as strong electrolytes at low concentration, and at high concentration they form aggregates and behave like colloid solutions. Some of the substances at low concentration behave as strong electrolytes, and at high concentration they form aggregates and behave as colloidal solutions. These aggregated particles are called as micelles, or they are known as associated colloids. At higher concentration, when they form aggregates and behave as colloidal solution, they are called as micelles or associated colloids. Formation of micelle. This formation of micelles or aggregates takes place above a particular temperature, and that temperature is called as Kraft temperature, Tk. When the aggregates form, they should have a temperature. Above a particular temperature only they will form aggregates, and that is called Kraft temperature. And above a particular, this happens above a particular concentration, and they are called as critical micelle concentration or CMC. The temperature should be what? The temperature should be greater than the Kraft temperature, that is represented by Tk. The temperature should be greater than Kraft temperature, and also the concentration should be concentration also should be greater than what? CMC, critical micelle concentration. These are the two important criteria for the formation of associated colloids or micelles. And also they have both what? Lyophilic and lyophobic parts. For a micelle or an aggregated associated colloids, they will have both lyophilic and lyophobic parts, and surface active agents like soaps, detergents, etc. form what? Micelles. Detergents and soap form micelles, and the critical micelle concentration for the soaps is what? 10 power minus 4 to 10 power minus 3 mole per liter. This is the critical micelle concentration of soaps. Also detergents also form micelles.
Students, we discussed today about colloids, the criteria and the classification, different types of classification of colloids. That's all for today's class. Thank you and have a nice day.